We have in today an Asus ROG laptop. This one has had a screw dropped on it while I presume the customer was doing something inside, but the battery was still connected and it's caused a spark and there's now what looks like no screen. And we can see this is the laptop, and if we press the power button, we can notice here we have the indicator lights. It's not charging at the minute, so let's just plug in the charger. And you can see we have the indicator that the hard drive is working, the battery's charging. And as you hear there, it's also got the boot sounds. Let's just test if we have HDMI out. Let's just see if we get anything on screen, and we don't that way. Let's just check in case it has USB-C display as well, and unfortunately not. Now we're inside the laptop. We want to take a general look around and familiarize ourselves with these. The more you work on them, the more you'll get used to specific layouts and specific manufacturers. For now, all we can see is we have, for example, battery here. We have empty connectors here for RAMs and hard drives. This one's got a hard drive in. You've got your ports. If you follow these leads, you'll often find where they go and what they relate to. So if this one goes all the way up into the hinge and into the screen, this will be related to screen. You'll see the same over here, going up into the hinge. So it's likely these two are related to screen. And then as we just look more, we can obviously identify specific chips. You'll have the GPU and CPU under here. And I think what we want to do, because the customer mentioned they dropped a screw on it, they haven't really told us where. Let's just strip this down further so we can do a full visual inspection. Now the first thing I can see, as soon as I've removed the heatsink area, the vapor chambers, is the GPU, which is this Ryzen 7, has liquid metal all over the place, including what looks like under this Kapton tape. If so, this is 100% going to have shorted out. So let's just recover all this and take a look if it has seeped under here. And the goal here will be, let's just try and remove the layer that's actually on top, so we can see if there really is anything underneath. Because if there is, as I mentioned, that's pretty much going to be a dead GPU, almost guaranteed. And there's also burn here where it hasn't had enough liquid metal. And we can see with that cleaned off, although it does lap underneath, it doesn't appear to have gone onto any of the capacitors. Visually inspecting the entire board, front to back under the microscope, all under these shields as well, I can't see a single thing that looks burnt or damaged, so there's no obvious visuals. I think the next thing to do is connect this all back up and monitor to see if the GPU is actually warming up. And just one more thing to note as we're reassembling, you can clearly see here, that's PW for power. This ribbon goes along up to the power button. This one is BL, so very likely this is backlight. It's also indicative of two very heavy planes. This is TP, which clearly goes to touchpad, so we know what that is. KB is keyboard, and you can see, you get the idea, BAT. So as we're reconnecting camera, we'll get the ideas of what is what, and that helps us understand where to probe. And thermals are all looking completely fine, everywhere we can see. So with a fan running constant, some heat sinks on, we can leave the computer running and probe the voltage rails. So you can see we've got 0.7 there, 0.9 there, which is fairly common, 0.3 on all these rails, which I think seems a bit low. I've never really seen a graphics chip run at 0.3 volts. That could be a sign that this is sinking too much power and pulling it low. And of course we'll have the main 20 volt rail, which we do. We have the 5 volt rail, the 3.3 volt rail. You can see the CPU running at 1.2 volts. That's what I expected the GPU to be running at. So these are similar power rails. Yeah, the GPU is at 0.3 volts. That doesn't, to me, seem right. And through this wonderful contraption of a setup here, resting the multimeter in, measuring the V-core on the GPU with a fan blowing at it, we can see it is 1 volt. But then once it boots and attempts to boot, this dips and drops to the 0.3 volt. So my guess is when it's booting, there you go, see it dropping, it can't handle the load. That's when it's enabling the GPU, sorry. So as the computer tries to enable the GPU, so this is kind of all pointing towards the GPU failure. There's no shorts on these MOSFETs. The power rails are all correct and handling the correct voltage output, but it just simply can't enable the graphics. So I think the CPU just disables the graphics card after a few failed attempts at booting. And you can see nothing on screen. So based on what I can see here, and the fact that during boot we do actually see the CPU enable the GPU and the voltage rail dip, I don't think there's much we can do bar swapping the GPU. We could swap all the MOSFETs, but I've already tested all these with resistance and diode mode and they're fine. I've tested the inductors. The caps are unlikely to be the culprit, so I think this is going to end up going down a rabbit hole and possibly no fix, because we saw the thermal paste on the GPU and the burn patch, so it's quite possible this has burnt out, and it's definitely pointing that way. Considering that we also don't get HDMI out or USB out, which would require the graphics chip to be working, I believe, it's all kind of pointing there. So although we didn't fix this one, we learned quite a bit, and the more we do, specifically on certain models, the more we'll learn. We'll have donor parts to be able to hot swap things and figure out more. But in this instance, I don't think there's much further we can take this without it being too expensive for the customer. This will, however, be a very useful board for diagnostics. It's not going to be much use for the customer, so I will offer to buy this in for donor parts. And then on future jobs, we have MOSFETs we can use, power ICs we can use, which you can't really buy on the market. You have to take off donors. So it's not a complete waste of time. So unfortunately, the best assumption and the best knowledge we have at the minute is pointing towards a GPU failure. If we keep this as a donor and in future repair more and learn more knowledge, we might be able to jump back on this and eventually resurrect it. But for now, I think that's it on this one, guys. I hope you learned something, and I'll catch you in the next.